Hello and welcome to the Friday, May 14th, 2021 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. We got a new cross-browser fingerprinting technique that comes from Konstantin Darutkin from fingerprint.js. Fingerprint.js, of course, a fingerprinting JavaScript library. And what he found was an interesting cross-browser vulnerability that allows you to identify a user possibly even if they're using different browsers. So often privacy conscious users will use one browser for example, more sensitive sites and another browser for business sites. And of course, different browsers keep different cookies, different extensions and such. So typically there is little crosstalk between browsers and information sort of stays separate to each browser. But what Konstantin found is there is one interesting issue that's identical for both browsers or all browsers on the system and really more a feature or property of the system the browsers are running on, and this is registered URL schemes. So typically, if you think about a URL, you think about something like HTTP colon or HTTPS colon, which would be the schemes here for these URLs. But various applications that are installed are able to register their own schemes, like for example, Skype colon. So if you are clicking on a URL that starts with Skype colon, then of course there will be a pop-up offering you to use Skype. But what's less known is that the browser can actually check which URL schemes are registered. And that's exactly what this fingerprinting technique does. It essentially enumerates software installed on your system. Now, they can't figure out all software that's installed in your system, only software that has registered a URL scheme. As part of their proof of concept, they're testing 24 different applications. And of course, that results in a 24-bit ID that they can use then to identify you, since all browsers have access to the same URL schemes on a particular system. This ID will be the same on all browsers. Of course, the real question is how unique this identifier is, and I think that's a little bit questionable here. There are a lot of applications that probably many users have installed. Let's say Skype, Zoom, Slack, for example, would be some of them, or iTunes, which is one of the applications they're testing on Mac. Pretty much any Mac will have iTunes installed, and that, of course, will provide less of a sensitive identifier. But then, for example, you have Visual Studio Code. That's kind of interesting because it may allow you to identify developer, same Xcode on Macs. So interesting research. Schemeflood.com is the URL for the little proof of concept test. And this is really a problem that sort of has to be addressed by the browser. One option would be to only allow these checks if they're actually triggered by a user's gesture. That happens, for example, with pop-ups and the like, or do provide some kind of alert to the user that a site is attempting to enumerate these URL schemes. And Cisco fixed a vulnerability in the Cisco AnyConnect secure mobility client that was originally made public in November, and for which also an exploit is already available. Now, what made this less of a big deal as it sort of sounds if you listen to the summary is that in order to exploit the vulnerability, an attacker would already have to have access to the system on which the client is running, and essentially the attacker could then only trick the user that runs the AnyConnect client to execute arbitrary code. Typically, the AnyConnect secure mobility client would run on a system that, for example, a user working from home or from the road is using. So these are typically single user systems, and if there is an exploit running on that system, it probably already runs with the privileges of the single user that's using the system and running AnyConnect. Insofar, yes, it's a code execution vulnerability, but not necessarily super severe. Cisco rated it nevertheless as high. And attackers seem to have a never-ending supply of tools that are already installed on the operating system that they find use for. These living off the land attacks, of course, have been a big thing over the last few years, in particular in the Windows world. The latest target here is MSBuild. MSBuild is a tool that is installed on Windows systems to build software, and typically you use an XML file in order to provide instructions to MSBuild as to how and what software to build. One of the particular useful features here of MSBuild is to compile code and execute it in memory, so you never end up with any files. And this is according to the blog post by Anomaly, who looked at a particular instance here to then use to create fileless malware. Particularly, they saw this being used to build the Remco's rat and redline, which are basically backdoors and info stealers. Anomaly also provides various indicators of compromise that they have observed. Well, that's it for today. Thanks for listening. And remember, next week is RSA. On Monday, I'll be speaking with Jason Lamb on modern web application threats. And then on Thursday, I'll be again part of the SANS top threats panel. Thanks, and talk to you again on Monday. Bye.